Welcome to the Spelling Bee Ninja podcast, your go-to resource for exploring fascinating educational concepts. Join us on this journey as we delve into the world of logic and reasoning. If you're eager to expand your knowledge and fuel your curiosity, make sure to subscribe for free educational content that aims to inspire and empower learners everywhere. Let's get started. In today's lesson, we will explore inductive reasoning, a powerful method of logical thinking where conclusions are derived from specific observations or patterns to form general principles. This form of reasoning takes us from the particular to the general, using evidence to create hypotheses. You might be wondering why this approach is so important. Well, inductive reasoning is often referred to as bottom-up logic, as it starts with specific examples and builds up to a broader conclusion. For instance, if you notice that every swan you've seen is white, you might conclude that all swans are white. However, there's a catch: unlike deductive reasoning, which guarantees certainty if the premises are true, inductive reasoning doesn't offer the same level of assurance. The conclusions reached through inductive reasoning are likely but not certain. This underlying principle is crucial in scientific discovery, where scientists use observation to identify patterns that help develop theories explaining the phenomena we encounter in our world. For instance, you might predict that since the sun has risen every day for your entire life, it will rise again tomorrow. This form of reasoning is not just limited to science, though. We often apply it in our daily lives as we assess experiences and make predictions based on our past. But the concept isn't without its challenges. One of the biggest philosophical debates surrounding inductive reasoning is known as the problem of induction. Famous philosopher David Hume raised critical questions from the 18th century, asserting that while we assume the future will resemble the past, such an assumption can't be justified logically. Hume's argument suggests that our belief in induction relies on habit or custom rather than solid reasoning, creating a complex landscape for understanding how we interpret our world. Despite Hume's challenges, induction remains essential in both science and our everyday lives, encouraging us to make informed predictions about the future based on our experiences. Moving on, it's important to note the main difference between inductive and deductive reasoning lies in the certainty of the conclusions drawn. Deductive reasoning ensures certainty if the argument's premises are true, while inductive reasoning produces conclusions that can always be revised as new evidence emerges. This methodological difference has significant implications for various fields, including science. Inductive reasoning is also frequently called probabilistic reasoning, emphasizing its reliance on likelihood rather than certainty. An excellent example to illustrate this is when you observe that 100 consecutive swans are white, you'd likely believe that all swans are white. However, encountering just one black swan would invalidate that conclusion, showing just how fragile inductive reasoning can be. The problem of induction pivots around this uncertainty, and Hume's discussion of it has sparked ongoing philosophical debate where some contend that induction may be justified through probability theory or alternative approaches. Now, let's touch on some of the various types of inductive arguments we encounter. These include generalizations, analogies, causal inferences, and predictions, each serving a unique purpose in our reasoning processes. Generalization allows us to make broad claims based on specific examples, yet it hinges on the sample size's representativeness. For example, scientific studies often necessitate large, diverse samples to ensure the conclusions drawn reflect a comprehensive picture of the population. Contrast this with the logical fallacy of hasty generalization, whereby sweeping conclusions are based on insufficient evidence. Think about the assertion, "I met two rude people from that city, so everyone from that city must be rude." Such reasoning overlooks the necessity of substantiating claims with adequate evidence. Additionally, we must examine analogical reasoning, which draws conclusions based on similarities between two things. It operates under the assumption that if two subjects share known characteristics, they are likely to exhibit similarities in other areas as well. Analogies serve as useful tools in various fields, including science and law, but the strength of an analogy is fundamentally tied to the relevance of the identified similarities. If the similarities are superficial or unconnected, the conclusions drawn may lack validity. Furthermore, we have causal reasoning, which infers a cause and effect relationship between events. However, caution is necessary because correlation does not imply causation. Just because two events occur concurrently does not mean that one causes the other. For example, reduced instances of ice cream sales in the winter may coincide with decreased drowning deaths. However, the truth is that a third factor, such as the temperature in summer, could explain both occurrences without any causal link between eating ice cream and drowning. Therefore, understanding the distinction between correlation and causation is critical, especially when evaluating scientific claims. Inductive reasoning also plays a foundational role in the scientific method. Scientists begin by making observations, identifying patterns emerging from these observations, formulating hypotheses, and, ultimately, testing those hypotheses. This process exemplifies how we move from specific observations to broader general cultural theories. Although induction leads to the creation of hypotheses based on prior knowledge, it remains provisional at best. Scientific theories are subject to change or rejection should new evidence arise. Throughout the history of science, countless theories were accepted for extended periods only to be overthrown when faced with new findings. This highlights the power and limitations of inductive reasoning as essential to fostering advancements in scientific knowledge. Another common obstacle encountered during this process is confirmation bias, which refers to the tendency to seek out and interpret information that aligns with our existing beliefs while neglecting or dismissing contradictory evidence. This bias can lead to flawed conclusions and is a critical error in inductive reasoning. Research has shown that even experts are prone to this bias. For instance, when a scientist subscribes strongly to a particular hypothesis, they may present studies that favor their viewpoint and overlook those that counter it. In our everyday lives, this behavior can be seen when individuals gravitate towards news sources that reinforce their political beliefs while dismissing opposing viewpoints. Overcoming confirmation bias requires a conscious effort to seek disconfirming evidence and consider alternative explanations. This ability is crucial for promoting scientific literacy and effective critical thinking skills. Lastly, let's reflect on the essence of inductive reasoning itself. It empowers us to learn from our experiences and make projections about future events. While it is indispensable in scientific inquiry and everyday decision-making, we must also recognize its limitations. Inductive conclusions are inherently tentative, open to revision in light of new evidence. Despite induction's constraints, it remains our primary means of discovering new knowledge about the universe. In contrast, deductive reasoning only confirms what is already present within its premises. This distinction enables us to unveil groundbreaking insights ranging from fundamental physical laws to the mechanisms underlying diseases. Cultivating an awareness of both the strengths and weaknesses of inductive reasoning is vital for effective critical thinking and informed decision-making, particularly in our increasingly complex and uncertain world. Today, we explored the fascinating world of inductive reasoning, discovering how it shapes our understanding of patterns and evidence. We learned that this method of reasoning is foundational to scientific inquiry and daily decision-making. Unlike deductive reasoning, the conclusions we draw from inductive reasoning carry a degree of uncertainty, requiring us to remain open to new evidence and revisions. We also touched on essential topics such as generalizations, analogies, causal relationships, and confirmation bias, each playing a pivotal role in ensuring our reasoning is robust and accurate. Understanding these concepts empowers us to navigate the complexities of rational thought and scientific exploration. Thank you for joining us today on the Spelling Bee Ninja podcast. We hope this exploration of inductive reasoning has sparked your curiosity and will help you approach information with a critical mindset. If you enjoyed today's episode, please consider subscribing for more educational content. We look forward to having you with us next time as we continue our journey through the topics that matter to you.